Hi friends, myself Aniket Renavikar, Assistant Professor, Center for Distance Education, Shivaji University, Kolhapur. In the program MCom Valuation of Real Estate, there is in semester second, the subject is a building construction. In that subject, there is a topic is a soil engineering. So today we learn about the soil engineering. In the soil engineering, the branch of engineering involving the study of soil, its behavior and application as an engineering material, while the application of the laws and principles of mechanics and hydraulics to engineering problems dealing with soil is usually referred in the soil mechanics, or it is also in the term of the soil engineering. Currently it is used. Soil is a natural powder of rocks which may contain air, water and any other substance lying therein, and which is used for construction and plantation purposes. There are various constituents of soil. Soil has three constituents, namely soil particles or solids, air and water. These three constituents are blended together to form a complex material. This complex material is called as soil. The space occupied by air and water in a soil is termed as the voids in the soil segment. There are various properties of soil component, that is gravel and sand, silt and clay, organic matter, etc. There are also the types of soil as per their sizes, particle size distribution. In that the clay is less than 2 micron or less than 0.002 mm. Silt is occurs in 2 micron to 75 micron, that is 0.002 mm to 0.075 mm. Next is the sand. Sand is a 75 micron to 4.75 mm, means 0.075 mm to 4.75 mm. In the sand there is a other three types, that is the fine sand, medium sand and coarse sand. The fine sand is referred to the size 0.075 mm to 0.425 mm. Medium sand is 0.425 mm to 2.0 mm, and coarse sand is a 2.0 mm to 4.75 mm. Next is the gravel. Gravel is belongs to the 4.75 mm to 80 mm, and these are also have the two types of gravel, that is fine gravel and coarse gravel. Fine gravel is between 4.75 mm to 20 mm, and coarse gravel is a 20 mm to 80 mm. Next is a cobalt, that is 80 mm to 300 mm, and next is a more than 300 mm, there is the boulders. In the soil, there is the main part is the bearing capacity of soil, that is the bearing capacity of soil is the conventional method of foundation design is based on the concept of bearing capacity. The foundation are designed that the stress induced in the soil are within its capacity and called a bearing capacity. If the soil is overstressed, a shear failure may occur, causing the soil to slide sideways from underneath and cause its failure. So we can use the safe bearing capacity of soil. In the safe bearing capacity, the maximum pressure which the soil can carry safely without risk of shear failure is called safe bearing capacity. Ultimate bearing capacity divided by a reasonable factor of safety is called as safe bearing capacity. The design of foundation is done for the bearing capacity. Factor of safety in foundation design range from 3 to 5 or even more. The value of factor of safety will be dependent upon the importance of structure, differential settlement it can stand, and the soil strata underneath as executed by the soil profile at the site. There are various factors to be affecting the bearing capacity. In that, the types of soil, its physical properties, amount of allowable total and different settlements, position of water table, physical features of the foundation such as types of foundation, size and shape of foundation, rigidity of structure, etc. are the factors that are affecting the bearing capacity of soil. So there are various methods to be improving this bearing capacity, that is the compaction of soil, proper drainage of soil, increase in depth of foundation, increase the width of foundation, grouting process, use of chemicals and replacement of pure soil. These are the methods which are improving the bearing capacity of soil. There are various methods to check the bearing capacity, that is plate load test, compaction, etc. used. For the compaction, the process of packing soil particles closely together by mechanical means, thus increasing the dry density of soil. By this process, reduction in voids of soil mass takes place rapidly by the blow of hammer or due to vibration or by passing a roller. So that compaction of loosely placed soil mass is necessary to achieve the desirable properties towards the better performance of the deposit. So there are main purpose of the compaction is this. There are various objectives of the compaction, that is to increase the density and shear strength, to reduce the permeability, to reduce the post-construction settlement, to reduce the danger of piping, and increase the resistance towards the erosion. So there are various factors to be affecting the compaction, that is the types of soil, amount of compaction, and water content and admixtures. So these are the various parts of the or various information regarding the soil engineering. In that we can see about the soil definition, particle size distribution of the soil, types of soil, compaction, methods of types of bearing capacity, factors affecting bearing capacity, etc. Methods of improving bearing capacity we can see in this lecture. So friends, today we stop here. These are all with reference to the self instruction material prepared for the MCOM valuation of real estate subject by Center for Distance Education, Shivaji University, Kolhapur. So friends, today we stop here. Any doubt, any query regarding this topic, you have directly mail on following mail ID cde_multi@unishivaji.ac.in.